bridges have specific characteristics. First, the dynamic interaction between the train and the structure cannot be neglected because of the heavy mass of the train. And then in this case, we have quite well-known forcing loading because we know the kind of trains and the velocities, the usual velocities of the trains passing on the bridge. So we are exploiting an approach based on the generation of wavelet plots, time frequency wavelet plots, and the application of convolutional neural networks to the images, the wavelet plots, to detect damage. Since the velocity, the structural response is very much dependent on the train velocity, as you can see on the right, we need to train several networks depending on the velocity and then find an intelligent way to choose between the most proper network to identify the damage. The second topic I would like to talk to you is automated inspection. So the idea here is to find a procedure, develop a procedure, a drone to damage fully automatic procedure to avoid the intervention of humans, of operators in the process of inspection, which is necessary for bridges. Now the newly issued Italian guidelines provide a standard methodology to perform inspections, periodic inspection, and how to assess risk. So we have strict requirements for them, and this has to be done, but we would like to make things easier, avoiding safety problems, accessibility problems, reducing time and cost of this operation, and even reduce the problem of subjectivity of the judgment when operators do this. So the idea is to use survey based on UAVs and then photogrammetry to obtain orthophoto on which we can do damage detection. So this is the idea. We perform several flight missions with drones to get a lot of images. We perform image matching and then build sparse and then dense point clouds. Finally, we texturize the model using the original photographs, and then we can get this orthophoto. This is a crucial step of the procedure. Orthophoto are planar views perfectly parallel to the surface of the element we want to investigate. This gives us the advantage of knowing exactly which is the dimension of the defect, because we can relate. If we know the resolution of the camera, we know the flight distance of the drone with respect to the element, we can exactly quantify the extension of damage because we can relate the pixel dimension to the real dimension. On this orthophoto, it's possible to apply damage detection algorithms. Here we use the simple one based on the YOLO tool. We selected two damage classes, corroded rebars and traces of drainage, and even if we had a quite small training data set, we were able to identify quite well the selected damage classes. Third part of the presentation, third topic, territorial scale SHM. So what's the problem here? First, we need, as usually when we deal with artificial intelligence, a large amount of training data for obtaining a good generalization of the algorithms. Then we need damage data. And that's a problem because in reality, they are, fortunately, they are not available. So we have, in general, scarce information. The idea here is to try to exploit, to use information obtained from other bridges to infer knowledge related to different bridges. In Italy, for example, we have a lot of similar bridges built in the same period with the same construction technique, material, and so on. So we have many similarities between many bridges. So we can consider, the idea is to consider several bridges sharing similar characteristics and use them to get information in the framework of the population-based structural health monitoring. So in this framework, labels are acquired from a population of structures, of bridges, and then we exploit transfer learning strategies to transfer knowledge from a source domain for which we have labeled data to a target domain for which we have unlabeled data. Among the transfer learning algorithms, we selected the transductive transfer learning. In particular, we use domain adaptation, which is a subfield of transfer learning, which aims to reduce the gap between the source domain and the target domain. Source domain and target domains are intended in terms of features. Let's go quickly. We used two different approaches. And here is the methodology. After alignment of the domains, it's possible to apply damage detection and classification algorithms. Here you can see some results related to two bridges, similar bridges, the Z24 I mentioned you and the S101. You can see that before domain adaptation there was a big distance between the two clusters of data of the Z24 and the S101, and after domain adaptation, the healthy data of both the bridges in black are well separated from the damaged data of both the bridges. We did the same with the numerical models because with the numerical models, with the finite element models, we are able to generate different types of damages and so get much more information, and also in this case we find it very effective. And another thing we were able to understand is that there is no need that the different structures, the source and target structures, have exactly the same structural scheme and the same geometrical characteristics. We can also transfer information from bridges with two peers to one bridge with one peer. And now we are studying similarity requirement to get exact information on how to select bridges on which transfer learning can be done. The last thing I want to show you is this one. This is an experiment that one of our PhD students performed at the University of Sheffield under the supervision of Keith Warden. She built a mock-up bridge, 3 meters long with, in aluminum with different piers, and she tested different configurations with different type of damage supplied. Here you see the effect of temperature. We tested it on different situations because the mock-up was in an environmental chamber and different damages were reproduced. And we saw that in many situations it was possible to transfer information using domain adaptation. The use of more than one bridge for training, the use of a set of bridges for training helps improving the accuracy, the detection accuracy. So in conclusion, machine learning has deeply entered in the field of bridge SHM for the purpose of data analytics, damage detection and classification, predictive risk analysis and decision making. artificial intelligence-based approaches are still in the face of scientific understanding, mainly due to the limited amount of available damage data for field validation and the necessity of cross-field scientific interaction between civil engineering and computer science experts. The idea for the future is not only to develop these procedures at the level of single asset, but also at the level of multi-asset, where we can exploit information and transfer information between bridges. I would like to thank you for your attention. This is the research group I would like to acknowledge. And I would like to acknowledge University of Perugia and Consorzio Fabre for the support. Thank you very much.
Thank you, Professor Venanzi, for sharing your expertise. Finally, we have Professor Dr. Harald Scham from the University of Vienna, an expert in development and change management. His research is essential for understanding how institutions can adapt to change. Bitte begrüßen Sie gemeinsam mit Professor Harald Scham.
Thank you very much. Yeah, okay. Thank you very much for the invitation, for inviting me. I'm changing a little bit the topic, and I also have been asked to be a little bit shorter, which I easily can be. Because I just want to give you a main message. We have been hearing quite a lot now about technology, but we heard about health monitoring in bridges, but I would like also to talk a little bit about health monitoring about our young children, because this is important also when we think about technology, building cities, building villages, giving them the possibilities to be active, the children to walk in the city, to bike in the city, to move actually. So it's about physical activity in childhood and adolescent, what I would like to talk about. How can I change it? You have to point it here. Is there?
May I? You have this, you have to point it there.
Okay.
At the computer.
Thank you. Could you change it manually? Yeah, okay. So, just to give you some idea how physical activity should look like. When we look at the recommendations of the World Health Organization, children and adolescents between the ages 5 to 17 years should achieve at least 60 minutes of moderate to vigorous physical activity every day. More would be better. So the new recommendations even tend to be higher, to be 90 minutes a day of physical activity. And if we look to smaller children, it's in reality, it should be 3 hours. Those children from 3 years up to 5, 6 years should be active 3 hours a day, should be active, physical active 3 hours a day. And if we look to the what is going on here, if we see that children are not active enough in reality. What we see is in reality that looking of children 11 to 17 years old, that more than 80%, 81% spend less than 1 hour doing moderate to physical activity every day. And in reality, what we also see here on this chart is that physical activity has decreased tremendously since the 1960s, actually. It has decreased, here is an example of the US of approximately 50%, and it has decreased in Europe of approximately 35%. And this is related then to quite a lot of yeah, I don't know why it's changing so fast. Yeah. What we see here, I took some pictures from Pristina. It's in reality what we are seeing here is a lack of green spaces, of areas where children can move sufficiently. And even I'm thinking all the time when I'm coming here to UBT from the hotel, it's not really safe to walk. And it wouldn't be safe for children as well to come here. There's no possibility, or you hardly see someone biking here in Kosovo. So this is a problem. So, and this is also something what we see. Okay, we can go to Kermia Park, but there should be possibilities close to cities, close to villages, where children can exercise, as we see here, best way, starting with the parents to exercise, doing it together. Because if we look if we look what is going on, we see that if children get older, that the amount of physical activity is going down. It's going down tremendously in reality, and this has negative consequences on not only on the health side, with significant increases of morbidity and health problems which arise, but there are also social, intellectual, emotional, and mental problems which are connected to that. And if we look, what are the effects for children on the motoric side, we see that there had been a reduction of 25 to 30% since the 1970s. So we see it, there had been a study in Austria that currently, I mean, we have at our university at sports science, they have to do an entrance exam. And the generation of the parents of the current students had been running faster. This 2,400 meter run, what they have to do, they had been faster by almost 2 minutes. So you see that children are getting worse in terms of exercise performance. So the exercise performance is decreasing, but it's not only the exercise performance, endurance performance, but it's also strength, power, speed, which is decreasing. And what are the reasons? And here we come also to the field which we are working here at UBT. It's one of the reasons is digitalization, it's urbanization, it's the inactive lifestyle, and this leads to an increase in overweight and obesity, and this is a tremendous problem actually, as we see that this is connected to many health problems. And what we also see that specifically now after the COVID-19 pandemics, these problems even get worse. Specifically in countries like Austria, where I'm coming from, where we had a lockdown, in this time, actually in our countries, the exercise performance even more decreased after that. What we see is there is a rise in blood pressure, in blood sugar, in other markers, in overweight specifically, and we see that this is the reason for many health problems, premature deaths actually, which occur based on that. We see here with the increase of overweight, obesity, that other diseases, cardiovascular disease, high blood pressure, high cholesterol, stroke, arthritis, and these things increase not only in the adult population, in the older population, but starting already in childhood. And as I was asked to be shorter, I would like to finish here just mentioning that we should think by all technical developments which we are looking for, that we also should have a look on that, what it means to have a technical development, not thinking about the surrounding, to have an environment where children can play safe, move safely actually, and this is just a short take-home message from my side. Thank you very much for your attention. Thank you.
Thank you, Professor Chan. As we proceed with our conference, I would like to inform you that the sessions for each department will continue in various classrooms at UBT. Please check the agenda for specific location and time. We encourage you to participate actively, engage our esteemed speakers, and make the most of this opportunity to expand your knowledge and network. A big thank you to all our sponsors, especially for general sponsor Penetron. Your support make a difference. Thank you once again being here, and let's make this conference a memorable experience together. Thank you.